All right, today we're looking at chain rule and higher order derivatives. Normally, if we see a derivative like this, we'd have to multiply it out. We'd either have to do it as a product rule by doing f of x equals 2x minus 3 times 2x minus 3, or doing f of x equals 4x squared minus 12x plus 9, where we actually fully multiply it out. What we're looking at today is a way to solve it, find this derivative without multiplying it out, and that's what we call chain rule. Now, chain rule, this process can be done for as many interior functions as you can find, but for now we're going to be focusing on two. You could see ones with 3 or 4 composite functions. So when we're doing chain rule, it's the derivative of the outside function with the inside function staying exactly the same. So g of x stays g of x, we're doing the derivative of the outside, times the derivative of the inside function. Okay? Now, let's take that one that we just looked at and look at how that applies. The outside function here is something squared. So when we take the derivative, we'll treat it like it's just an x being squared. We'll pull down the 2, we'll leave the inside exactly the same, and then we'll subtract 1 from the power. Then multiply by the derivative of the inside. Well, the derivative of 2x minus 3 is just 2. So this would be 4, and then 2x minus 3. And so if you go back to these and work them out, either as product rule or like this, you'll end up getting that same answer. It might not be factored, but it'll be the same answer. Okay, so we have some problems like this that we can look at as practice. So sine of 2x, for example. The big thing with chain rule is identifying what is the inside, what is the outside. Well, here, sine has hidden parentheses around the 2x. So sine is the outside, 2x is the inside. So f prime of x is equal to derivative of sine is cosine x, it's cosine, but we leave the inside the same. So cosine of 2x times the derivative of the inside, which is 2. So 2 cosine 2x would be our derivative. For g of x, the outside function would be the cubed, the inside would be the 3x squared minus 3. So g prime of x, 3 parentheses, 3x squared minus 3 squared. This is the outside derivative, inside stays the same, times the derivative of the inside, 6x minus 0. And so we'd end up with 18x times 3x squared minus 3 squared. Okay? So a lot of this is just more practice. The big one I want to talk about here is number 1 on this page, the y equals sine cubed. As I said earlier, we can have multiple functions compounded on top of each other. We're just going to work inside or from outside all the way in. So this one needs to be rewritten as sine of 4x cubed. That's what that cubed there means. It's the whole thing being cubed. So the outside is the 3, or the cubed. So 3 sine of 4x squared times the next inside is the sine, so cosine of 4x. Notice in all this process, the most inside still hasn't changed. And then times the most inside function, the derivative of it, which is just 4. So we end up with 12 sine squared of 4x times cosine of 4x. And that would be our final answer. You can try number 2 as well there. All right. We could also do this while incorporating product rule. When things get a little more complex. So we have the first function, which is 2x minus 3 squared, times the derivative of the second. We're going to need chain rule for it. 3 times 3x minus 4 to the second times 3, plus the second function, 3x minus 4 cubed, times the derivative of the first. Once again, going to need chain rule for this. So pull down the 2, 2x minus 3 times the derivative of the inside, which is 2. And then we can simplify. Now, our simplification for this is going to start with pulling out common factors. Now, this should be almost any time you do something like this, especially when we look at some quotient rule ones in a second. So we have a 2x minus 3 in both of these, and we have a 3x minus 4 in both of these. And so we're going to pull out those. So 2x minus 3, we have a squared and a single power, so we can only pull out 1. 3x minus 4, we have a squared and a cube, so we can pull out a 4 or pull out squared. And then let's lift over. So we pulled out one of the 2x minus 3s, so we're left with a 2x minus 3. And then times 3 is still left. We pulled out both the 3x minus 4. We pulled out 3x minus 4 squared, so it's gone. Over here, we pulled out 2 of the 3x minus 4s, so we're left with 1 3x minus 4 times, we pulled out the 2x minus 3, so times 2 times 2. So we have 2x minus 3, 3x minus 4 squared, and then here, this is a 9, so 18x minus 27, plus, this is a 4, so 12x minus 16, 2x minus 3, 3x minus 4 squared, so it's going to be 18 plus 12 is 30x, negative 27 minus 16, it looks like is negative 11, and so there would be our final answer. Okay. Now we're also going to look at using these concepts when we don't have all the information. So we're given all this information about g and h, and we want to find these few derivatives. So the first one is f prime of 2. Well, what we need to find first is f prime of x. Well, that's product rule. We have g prime, or g of x, times h prime of x, plus h of x, times g prime of x. And then we can plug in 2 to these. So it's g of 2 times h prime of 2 plus h of 2 times g prime of 2. And that's all information we have up here. G of 2 is 3, h prime of 2 is 5, h of 2 is 2, and g prime of 2 is 4. So we end up with 15 plus 8, which is 23. You can do the same thing for v of x. I want to talk about w of x and look at how this one is. So we need w prime of 2. So we need to first find w prime of x. This is chain rule, so g of h of x, g prime of h of x, right? So the derivative of the outside times h prime of x, the derivative of the inside. When we plug in the 2, we're plugging it into x. So g prime of h of 2 times h prime of 2. H of 2 is equal to 2. So we have g prime of 2 times h prime of 2 is 5. Then we can go back up to the chart and see g prime of 2 is 4. So this is 4 times 5, which equals 20. Okay? Last thing we're going to look at is higher order derivatives. Higher order derivatives means taking the derivative more than once. So the second derivative would be what we got if we took the derivative twice. So f prime of x is the first derivative. We'll do a chain rule, 5, 3x minus 4 to the 4th times 3, which gives us 15 times 3x minus 4 to the 4th. The second derivative is just the derivative of that equation, and we denote it with an extra tally mark. Now we only use tally marks for about the first 3 derivatives. After that we use numbers. So the 4th derivative would just be f4 of x. 5th derivative f5 of x. All right, so we're going to take this derivative again. So 60, 3x minus 4 cubed times 3, which is 180, 3x minus 4 cubed. That's all higher order derivatives are asking about. So you can find specific number of derivatives, but there are some things you can look out for. Like for this one, for example, if you're finding the 5th derivative and the biggest power is 4, well, let's think about that. Every time you take the derivative, this power is going to subtract by 1. So you're then going to have x cubed, x squared, x to the first, x to the 0, which is a constant, and then 0. That's 1, 2, 3, 4, 5 derivatives. And if the biggest power eventually gets to 0 after 5 derivatives, then that means all these will also go to 0 at some point as well. So keep an eye out of how many derivatives you're taking and if you can find any shortcuts like that. So this derivative will not equal 0. F to the 5th of x is going to equal 0. It's not always going to happen, but you can also do something like that for the third one, or for the second one here, the third derivative, if you can notice what the pattern is. The big thing that this comes into play with is for ones like this. Find the 103rd derivative of sine. I want you to pause the video and try and find it yourself a minute. And then when you come back, we can look at it together. All right, so I'm hoping you paused and unpaused. Let's look. Let's just start taking some derivatives. Derivative of sine is cosine. Second derivative of cosine is negative sine. Third derivative of negative sine is negative cosine. Fourth derivative of negative cosine is sine. And then we can stop and say, oh wait, we're back to the beginning. So every 4 derivatives, we're going to be back to the beginning. We're going to be back to sine. So if we think of this as how close is this to the 4th derivative in the pattern, well, it's 1 less than 104. So 104 would be right here. We'd be back to the 4th derivative, which means 103 would be right here at the 3rd derivative. So the 103rd derivative of x is going to end up being negative cosine. There are only a few functions that do these, cosine and sine being the big ones, where it's going to repeat like that, and you can jump onto those patterns. Okay? If we were in class, we'd look at this one together and look at how this one would work. This one starts out really ugly, and then over time, as you get done with a couple derivatives, it becomes much cleaner. So you're looking for the 4th derivative there if you want to try that on your own. Okay? Last thing we want to look at is finding when a function is continuous and differentiable. We saw problems like this back when we very first started derivatives, but now we're going to look at them again now that we have all these tools at our disposal. Continuous and differentiable means the function is continuous and the derivative is continuous. So for the function to be continuous, ax squared plus 1 has to equal bx minus 3 when x is equal to 1. So a times 1 is 1 plus 1 equals b times 1 is b minus 3. All right? That's not enough information though. We have 2 variables, we need a system of equations. So we're going to find f prime of x. Taking the derivative, we get 2ax plus, well, derivative of 1 is a constant, so just plus 0. And then on bottom, we just get b minus a derivative of a constant is just 0. So this is x greater than or equal to 1. This is x less than 1. So now we can set this one equal to each other and create a second system of equations. 2ax equals b, and 2a times 1 is 2a equals b. And now we can solve for the other variable, whether you use the elimination method or whether you substitute it in. Very similar thing happens with the second one here, but I can let y'all solve those on your own. Okay, this is just more practice with looking at the different, like using different values we're given and solving a derivative. So you're free to work this one on your own. Let me know if you have any questions. With that, y'all are free to work on your worksheet. Come talk to me if you need to, or if you're just some random person watching, then thanks for watching. Y'all have a great day.